Tonight's video is looking at storms. This is probably everybody's favorite part of weather. We're going to talk about 4 types of storms tonight, and let's get started. So first off, a storm is any violent disturbance in the atmosphere. So this is a usually pretty short-term event that causes a lot of damage. It's got a lot of motion of the atmosphere, it's got a lot of wind, it's got a lot of precipitation of some kind, and there's a lot of stuff going on. So a storm is a violent disturbance in the atmosphere. And we're going to talk about 4 types of storms today: winter storms, thunderstorms, hurricanes, and tornadoes. So this is what's called a shelf cloud. It forms during thunderstorms, and we'll talk about those a little bit more when we get to tornadoes. So the first type of storm is a winter storm, and this is just any storm that occurs with large amounts of snowfall. So it's a little less specific than a thunderstorm or a hurricane, and a winter storm is just any big storm that brings lots of snow and winter precipitation. And it often has strong wind as well, and that sometimes you'll hear the term blizzard. Pretty much the same thing. So this is large amounts of snowfall, often with strong winds. And another thing we get from winter storms is something called lake effect snow, and this happens in the northeast of the United States near the Great Lakes. And this happens when winds blow across these lakes in the wintertime, and they pick up moisture and then dump that moisture on the far side of the lake. So a lake effect snow. Winds blow across the Great Lakes and dump moisture as snow. All right, so they pick up all this moisture as they blow across the lake, and then they dump it on the other side. And here's a diagram that shows that a little bit more clearly. Here is one of the Great Lakes. Let's call it Lake Erie. The water is cold, right? Those lakes are too big to freeze in the wintertime. They can't lose enough heat to get covered over with ice. So the water is about 32 degrees Fahrenheit. The land might be 0. So this cold air moves over the lake. The lake surface adds a little bit of heat and some water vapor, right? Water vapor condenses into clouds as it moves, and then snow falls on the downwind shore of the lake. And that's what we see in this picture here. These areas that are on the downwind side of the lakes get a lot of snow. And if they colored in the part in Canada that gets snow, that would also have a lot of snow right there. So that is winter storms. Next up, we've got thunderstorms. We're pretty familiar with these here in Atlanta. We get them a lot, especially in the summertime. All right, this is a small storm compared to the others, with heavy precipitation, thunder, and lightning. Small storm with heavy precipitation, thunder, and lightning. And this occurs when warm air is forced up rapidly. Warm air is forced up rapidly. And so as you can see in this diagram, this warm, moist air gets pushed up quickly. As it cools, it drops all its moisture out and forms this huge towering cloud. Right? These are our cumulonimbus clouds. And that moisture starts to get dumped out as rain. So we get these a lot at cold fronts. Right? The cold front would be over here on the left, the cold air pushing in, slamming this warm air up. We also get them a lot in summertime when just the sunlight heats up the air and creates these huge warm upward currents that creates thunderstorms. So along with our thunderstorm, we can get hail. And we talked a little bit about hail with precipitation, but hail forms when convection currents in the thundercloud. So this is within the cloud, we've got these currents going around and around. Convection currents in the cloud toss these ice particles through the cloud multiple times. So hail forms when, or rather just hail, we have convection currents in the cloud toss ice particles around multiple times. And the hailstone grows bigger and bigger with each trip through the cloud until eventually the hail gets too large for the cloud to hold and falls to earth. All right, depending on the strength of the thunderstorm, you get different size hail. The stronger the storm, the stronger these convection currents, the bigger the hail, because it'll take more and more trips through the cloud. So that's why we really don't see hail in many other storms, because we don't have these complex winds, these convection currents, to get the hail to form. All right, and then the last thing that comes with thunderstorms is thunder and lightning. All right, so for lightning, the motion of the cloud particles rubbing against each other builds up a static charge, just like when you shuffle feet on your carpet and then touch something metal. So the motion of cloud particles creates static charge, and eventually that charge difference sparks, and we call that lightning. Right? And so eventually that charge difference is so big that a bolt of electricity goes between the two to balance out the charges, and we call that lightning. And the heat from the lightning actually creates an explosive shock wave in the air, and we call that thunder. So the sound you hear of thunder is just literally the air around that lightning bolt explosively expanding as this electricity blasts through it. All right, and lightning sparks, and we'll go with that. So those are thunderstorms. Next up, we have hurricanes. All right, we're not super familiar with these in Atlanta, but if you have family or friends in Florida, they know all about these. All right, this is just a huge low pressure system that forms over the ocean, and it gets energy from those warm ocean currents. So it's a large low pressure system forming over tropical oceans, gets strength from warm water, and it has winds of over 119 kilometers per hour. And that's what defines a hurricane. And a little less than that, we call it a tropical storm. Below that, we would call it a tropical depression. So this is a satellite picture of Hurricane Irene, which was in 2012, heading up the east coast of the United States. So you can see it's spiraling because it's a low pressure system, right? The winds are spiraling to the center, where they're then going to come up in the middle. And it brings lots of heavy rain, and then this thing called the storm surge, and you can think of that as the hurricane literally pushing a wall of water on the ocean surface ahead of it. And that is not so fun if you are on the coast when that storm surge hits. And our last storm is a tornado. And we get these in Atlanta sometimes. This is a small, rapidly spinning cloud that reaches down and touches the surface. And so the color of the tornado is partly due to the cloud, but a lot of it is also due to stuff that it picks up from the ground. And so that's how you start to be able to really see the tornado. Sometimes you get more than one at once. All right, this is obviously a fairly terrifying picture with lightning and multiple tornadoes. And so this is a small, rapidly spinning cloud reaching down from a thunderstorm. All right, and this is caused by super rapidly warming warm air. So even within the thunderstorm, there are areas where you get a tiny little spiral of warm air getting forced upwards rapidly, and as it forces upwards, it starts to spin. And that spinning and that updraft creates the tornado. So it's rapidly, I'm going to underline rapidly because we mean rapidly, rising warm air. All right, and it usually lasts less than 15 minutes. But winds in a tornado can be upwards of 300 miles an hour. But fortunately, they're very small, and they usually are very small, and they don't last very long. So that is all for storms. I know that's a lot of information. For the test, I'm not going to ask you to remember every single little detail. You'll have to be able to kind of tell me what each type of storm is and how it forms, and that will be pretty much all that's required. So make sure you do a good summary. Make sure you fill out the survey after you do your summary, and I will see you in class tomorrow.